Assalamualaikum warahmatullahi wabarakatuh and every good day to my both panel, Dr. Rahmat and Dr. Zuhairah. My name is Nur Asyikin binti Shuib and my message number CE180061. I will present my final year project 2 with title Longitudinal voltage and induced voltage between linking cables in railway environment using simulation method. Introduction of this project is railway infrastructure include cable installation that important for safety and reduce the risk of accident in railway. Longitudinal voltage occur when unwanted electromagnetic wave interference with victim or adjacent cable and introduce unwanted induced voltage on the victim. Underground tunnel is a commonly routed for urban railways such as Mass Rapid Transit (MRT) and Light Rail Transit (LRT). Linking cable is commonly used for telecommunication medium as antenna to provide mobile service. Due to its characteristic of having slot on the surface of the router conductor that allow it to transmit and receive radio frequency RF signals. Linking cables is invulnerable if it is exposed to high electromagnetic fields, which will produce induced voltage inside the cables, so that in between linking cables and linking cables will produce longitudinal voltage induced voltage. For the problem statements, nowadays the underground tunnel communication system has relied on a linking cables antenna. In most cases, many wires have been put inside the tunnel. However, there is no minimal separation between distant linking cables and linking cables antenna installation that has been established. Has the number of cables inside the underground tube grow, the spacing between them narrow and become crowded. Linking cables is a cable that radiates RF signal, and if the separation distance between the linking cables are too close, it will produce longitudinal voltage induced voltage. Based on the principles, linking cables are electromagnetic waves that cause signals to leak around the cables. Electromagnetic wave radiate from the first cable main induced to the nearby another linking cables. Objective of this project is first to study the longitudinal voltage between linking cables and adjacent linking cables. Second, to design the linking cables antenna by using CST Suite Studio software. And lastly, to determine the minimal allowable separation distance between two linking cables. Scope of this analysis is use 1 meter linking cables, 550 ohms impedance, and the frequency range of 30 MHz to 270 MHz. The separation between linking cables to linking cables is 0.1 meter, 0.2 meter, 0.3 meter, 0.4 meter, and lastly 0.5 meter. The simulation method using electromagnetic simulation is CST Studio software. I will start with design linking cables by using CST simulation software. I will set the linking cables 1 with 750 MHz to 270 MHz, and the linking cable 2 I will set passive. And then I will set the separation distance between linking cables and linking cables with different distance, such as 0.1 meter until 0.5 meter. After that, after designs the cables, I will simulate the design using CST simulation software. After simulate the design, I will record the results. After that, I will do analysis. And lastly, I will write the thesis. Okay, this is the parameter for leaky cable configuration that I use in CST simulation software. Okay, this is the result of 1 meter linking cables. 1 meter linking cables simulation is carried out to observe the induced voltage reading if the cables is at 1 meter length. Both cables are terminated with 50 ohm impedance. Cable 1 is set to be active cables and cables 2 is set to be passive cables. And the voltage monitor is placed at the second cables because this is a passive to get the induced voltage. Okay, this is first result of 0.1 distance separation between cables. So that the graph show that the maximum induced voltage record is at 0.1 meter distance where the induced voltage value is 0.021 volt. Okay, this is the second result of 0.2 meter distance separation between cables. And the graph showed that the maximum induced voltage record is 0.012 volt at the 0.2 meter separation between cables. And next, for 0.3 meter distance separation between cables, and the maximum induced voltage is 0.008 voltage. And the separation between cables for 0.4 meter is the maximum induced voltage is 0.006. And lastly, for 0.5 meter distance separation between cables, and the voltage induced is 0.004 volt. If you can see that this is the combined result for every distance. The highest maximum induced voltage obtained is at 0.1 and it is obvious that the induced voltage decrease as the spacing increase. However, the induced voltage reduced from the simulation. The induced voltage at 0.3 meter distance linking cables is 0.008 volt. Based on the result, it showed that the maximum induced voltage when the spacing at 0.3 is close. The spacing increased from 0.3 meter to 0.5 meter. From the result, it can be concluded that the minimum allowable spacing for the linking cables to linking cables is 0.3 meter. However, some clients ask for more separation to install the linking cable, but with the data, it can be proved that 0.3 is enough because even if the separation increase, the value of the voltage induced will only change in a very small values. Thus, the minimum separation distance of the two linking cables is at least 0.3 meter to ensure the performance of the antenna is not harmed and work efficiently. As a conclusion of this project, longitudinal voltage between linking cables and linking cables in real environment has successfully designed and simulated by using CST simulation software. Designed linking cables are able to operate in the frequency range of the 3 MHz to 270 MHz, and the characteristic impedance is around 50 ohms. Then the allowable separation distance between two linking cables is 0.3 meter, where the maximum induced voltage is at 0.008 volt. It will be proposed as a guideline to the engineer on designing the cable's distance separation and cable's location in real environments. For recommendation is more study on another type of linking cables, as there are several types of linking that needed to be studied, as some of them are commonly used in telecommunications industry. Then get a accurate data sheet for each cable to get the best result. And lastly, design the cables with other simulation software to compare the result to get the best result, such as CheMax software and CMax software, and etc. Thank you for listening.